At first glance, the scientific publishing industry seems like a structured, impartial system, a way to share discoveries, evaluate research quality, and build the cumulative knowledge of humankind. But for many researchers, especially early career scientists, this system feels less like a meritocracy and more like a form of intellectual servitude. Scientists write, review, and edit papers, often for free, while giant publishing corporations charge exorbitant fees to access that same knowledge. This raises a deeply uncomfortable question. Has the traditional publishing model created a modern form of scientific slavery? And if so, could AI be the key to liberating science from it? Let's take a step back. In the current model, researchers do almost everything. They write the papers, conduct peer review, and often edit journals, usually without compensation. Meanwhile, publishers monetize this work, charging universities and readers thousands of dollars per journal subscription, or imposing high article processing charges, APCs, for open access. The irony is stark. The very people producing and validating knowledge must either pay to publish or pay to read their own field's progress. Add to that the endless cycle of impact factors, citation metrics, and gatekeeping, and it's easy to see why so many scientists feel trapped. And yet, despite widespread dissatisfaction, little has changed. Why? Because the academic reward system is deeply tied to the publishing system. Promotion, tenure, and grant success still depend heavily on where you publish, not just what you discover. As a result, researchers are forced to play the game even if they recognize its flaws. It's a system that feeds on unpaid labor, prioritizes prestige over accessibility, and leaves vast swaths of the world's knowledge locked behind paywalls. Now enter AI, a disruptive force not just for automation, but potentially for restructuring how knowledge is created, evaluated, and shared. Imagine a system where AI helps scientists draft, edit, and refine manuscripts, saving weeks of effort. But more than that, AI can assist in semantic indexing, plagiarism detection, peer review analysis, and even automated quality checks of data and methodology. Tasks that now take months could be reduced to days, if not hours. But the real revolution comes when AI is used not just to assist within the old system, but to replace it. Imagine a decentralized, AI-powered open science platform where researchers upload their findings directly. AI tools verify the structure of the paper, flag errors, summarize findings, check reproducibility, and even match reviewers based on expertise, eliminating the need for centralized publishers entirely. Peer review becomes transparent, fast, and global, with version tracking, open comments, and post-publication updates. Instead of a pay-to-weigh model, this system could operate on public infrastructure, supported by governments, universities, or blockchain-based micro-incentives. The value would shift from where you publish to how accessible, transparent, and reproducible your research is. Scientists wouldn't be trapped in a prestige economy, but empowered by an ecosystem that values collaboration, openness, and actual impact. Sound far-fetched? Not really. Early prototypes already exist. Platforms like arXiv, bioRxiv, and Open Review offer glimpses of a post-journal world. Add AI to the mix, and the infrastructure becomes scalable, intelligent, and more equitable. AI-generated summaries can make complex papers understandable to non-specialists. AI meta-analysis can scan thousands of papers to detect biases, trends, or contradictions across fields. And large language models could help researchers in developing countries overcome language barriers that once excluded them from the global conversation. So, can AI really save scientists from a system many quietly resent? It can, if we choose to build the right tools and systems. The publishing industry, as it stands, profits from inertia and prestige. But science thrives on disruption, transparency, and truth. AI gives us the technical capability to democratize knowledge, decentralize review, and dismantle gatekeeping. But here's the paradox. Technological solutions exist, yet the culture of academia resists them. The very people most affected, young researchers, independent scientists, voices from underfunded regions, often lack the power to force change. Senior academics and institutions still reward compliance with outdated norms. So while AI may be the key, the door won't open unless the community pushes together. Could AI be the printing press of 21st century science, breaking monopolies and opening knowledge to all? Possibly, but only if we stop asking for permission from the very institutions that profit from our silence. In the end, the question is not just how AI can replace traditional publishers, but when scientists will choose to stop fueling a system that no longer serves them and start building one that does. Traditional scientific publishers have long dominated the dissemination of research, often imposing high subscription fees and publication costs that many argue restrict access and place undue burdens on scientists. Critics contend that this system creates an imbalance where researchers contribute their work and peer reviews for free, while publishers reap significant profits, a situation some describe as exploitative. This slavery system of scientific publishing has led to calls for more open and equitable models that prioritize the dissemination of knowledge over profit. The debate has intensified with the advent of digital technologies, which expose the inefficiencies and inequities inherent in the current model. Many researchers are forced to pay hefty article processing charges, APCs, to publish in high-impact journals, even as their institutions struggle with soaring subscription costs. It's like artists donating their paintings to a gallery that then sells the artwork at a high markup without ever compensating the creators. Artificial intelligence offers transformative potential to streamline and democratize scientific publishing by automating tasks such as manuscript screening, peer review, and metadata indexing. AI-driven systems can quickly analyze the quality and novelty of research submissions, potentially reducing the time and cost associated with traditional editorial processes. By leveraging natural language processing and machine learning, these systems may also help in curating and disseminating research more efficiently. This promises a shift from a centralized, profit-driven model to a more open, community-oriented approach. AI algorithms are already being used to flag potential issues in manuscripts, such as plagiarism or statistical anomalies, before they proceed to peer review, expediting the process and lowering editorial costs. It's like having a highly efficient assistant who can quickly sort through thousands of job applications to find the best candidates, bypassing the need for an expensive recruitment agency. AI can bolster open access initiatives by facilitating the creation of decentralized publishing platforms that allow free, unrestricted access to research. These platforms can employ blockchain technology and AI-driven peer review to ensure transparency and integrity without the high costs associated with traditional publishers. Such systems could empower scientists to share their findings directly with the global community, bypassing paywalls and commercial gatekeepers. This democratization of knowledge has the potential to accelerate scientific progress and ensure equitable access to research worldwide. Initiatives like open access repositories, enhanced by AI for quality control and metadata curation, allow researchers to deposit their work, making it freely available to anyone with an internet connection. It's like replacing an exclusive club with a public library where everyone has free access to the wealth of human knowledge without a membership fee. AI has the potential to transform the peer review process by automating the initial screening of manuscripts, identifying methodological flaws, and even suggesting potential reviewers based on expertise and conflict of interest considerations. This can reduce the workload on human reviewers, speed up the evaluation process, and help eliminate unconscious biases that may affect editorial decisions. More consistent and transparent reviews could improve the overall quality of published research. By ensuring a fairer, data-driven review process, AI could contribute to a more meritocratic scientific landscape. Some publishers are experimenting with AI tools that provide preliminary assessments of a paper's novelty and rigor, thereby helping editors decide whether a manuscript should be sent for full peer review. It's like using an advanced sorting machine in a recycling plant that efficiently separates materials by type and quality, ensuring that only the best items move forward for further processing. One of the most immediate benefits of integrating AI into the publishing process is the significant reduction in operational costs. Automation of routine tasks, from editorial decisions to formatting and copy editing, can dramatically lower overhead expenses, potentially reducing publication fees for researchers. These savings could be reinvested in further research and innovation, alleviating financial pressures on academic institutions and individual scientists. An AI-powered system could thus create a more sustainable and efficient model for scientific communication. Startups that offer AI-based manuscript management systems are already lowering the time and resources required for processing submissions, leading to faster publication cycles. It's like replacing manual assembly lines with robotic automation in a factory, drastically cutting down on labor costs and production time. By bypassing traditional gatekeepers, AI can empower scientists to establish and manage their own publishing platforms that prioritize quality and accessibility over profit. Such platforms could allow for more rapid dissemination of innovative ideas, free from the constraints of traditional publication delays and high fees. The shift toward a more decentralized system could foster a collaborative environment where scientific merit is judged by peers rather than commercial interests. This model encourages transparency and shared ownership of research outputs, aligning with the ethos of open science. Collaborative platforms like ARX already enable researchers to share preprints freely. Integrating AI could further enhance these systems by automating quality checks and curating content based on community interest. It's like a community garden where everyone contributes and benefits equally, rather than a privately owned park with restricted access and high entry fees. Critics argue that traditional publishers effectively enslave scientists by extracting unpaid labor through peer review and charging exorbitant fees for access to publicly funded research. AI-driven solutions can disrupt this system by eliminating unnecessary intermediaries and returning control to the scientific community. By automating many functions that publishers currently perform, AI could help establish a more equitable framework for sharing and evaluating scientific knowledge. This shift may help alleviate the financial and bureaucratic burdens that many researchers face today. Some AI-in-depth platforms propose to automate editorial processes, peer review, and even grant distribution, creating an ecosystem where research dissemination is democratized and cost-effective. It's like revolutionizing a monopolistic market by introducing open-source alternatives that allow creators to connect directly with their audiences without exploitative middlemen. The transition to AI-driven, scientist-controlled publishing raises important ethical and societal questions about data privacy, algorithmic transparency, and the potential loss of traditional editorial oversight. Ensuring that AI systems operate fairly and without bias will be critical to maintaining trust in the scientific publication process. Additionally, the disruption of long-standing institutions may face resistance from established stakeholders, prompting debates about the future of scientific communication. Nonetheless, a more open, accessible, and efficient publishing model could benefit society by accelerating innovation and democratizing knowledge. Policymakers and academic institutions are increasingly discussing the need for regulations that ensure AI-powered systems in research dissemination are transparent and accountable. It's like upgrading from a closed proprietary software system to an open-source platform where the code is visible and can be improved collectively, despite initial resistance from traditional vendors. As AGI technology matures, governments and international organizations will need to establish frameworks for regulation and oversight. Policies must balance the promotion of innovation with the protection of individual rights and societal well-being, addressing issues such as privacy, security, and economic disruption. Global cooperation will be essential to set standards and prevent an arms race in AGI capabilities. Transparent, inclusive dialogue among stakeholders, including scientists, policymakers, and the public, is key to crafting effective regulations. Initiatives like the OECD's recommendations on AI ethics aim to create a coordinated international approach to guide the responsible development of advanced AI technologies, including AGI. It's like establishing international traffic laws to ensure that the rapid advancement of automobile technology leads to safer roads rather than chaotic competition. Future research will likely focus on integrating different AI paradigms such as symbolic reasoning, deep learning, and reinforcement learning to create systems that approach the versatility of human cognition. The path to AGI involves not only technical breakthroughs but also interdisciplinary collaboration that spans computer science, neuroscience, philosophy, and ethics. As AGI advances, its implications will continually reshape our understanding of intelligence and spark new debates about the role of machines in society. Ultimately, the pursuit of AGI represents both an extraordinary opportunity and a profound challenge for the future of science, society, and development. Cutting-edge projects in neuromorphic computing and brain-inspired architectures are paving the way for systems that might one day exhibit AGI, transforming everything from healthcare to education. It's like setting out on an ambitious journey to explore uncharted territories, where each new discovery challenges your old maps and compels you to redraw the boundaries of what is possible.